Let's learn a little bit about the wonderful world of logarithms. So we already know how to take exponents. If I were to say 2 to the 4th power, what does that mean? Well, that means 2 times 2 times 2 times 2. 2 multiplied or repeatedly multiplied 4 times. And so this is going to be 2 times 2 is 4, times 2 is 8, times 2 is 16. But what if we think about things in another way? What if we know that we get to 16 when we raise 2 to some power, and we want to know what that power is. So for example, let's say that I start with 2, and I say I'm raising it to some power. What does that power have to be to get 16? Well, we just figured that out. X would have to be 4. And this is what logarithms are fundamentally about. Figuring out what power you have to raise to get another number. Now, the way that we would denote this with logarithm notation is we would say log base, actually let me make it a little bit more colorful. Log base 2, logs, I'll do this 2 in blue, log base 2 of 16 is equal to what? Or is equal, in this case, since we have the x there, is equal to x. This and this are completely equivalent statements. This is saying, hey, well, if I take 2 to some x power, I get 16. This is saying, what power do I need to raise 2 to get 16? And I'm going to set that to be equal to x. And you would say, well, you got to raise it to the 4th power. Once again, x is equal to 4. So with that out of the way, let's try more examples of evaluating logarithmic expressions. So let's say you had log base 3 of 81. What would this evaluate to? Well, just as a reminder, this evaluates to the power we have to raise 3 to get to 81. So if you want to, you could set this to be equal to an x. Set that to be equal to an x, and you can restate this equation as 3 to the x power. 3 to the x power is equal to 81. Why is a logarithm useful? And you'll see that it has very interesting properties later on. But you didn't necessarily have to use algebra to do it this way, to say that the x is the power that you raise 3 to get to 81. You had to use algebra here. While with just a straight up logarithmic expression, you didn't really have to use any algebra. We didn't have to set it equal to x. We could just say this evaluates to the power I need to raise 3 to get to 81. The power I need to raise 3 to get to 81. Well, what power do you have to raise 3 to get to 81? Well, let's experiment a little bit. So 3 to the 1st power is just 3. 3 to the 2nd power is 9. 3 to the 3rd power is 27. 3 to the 4th power, 27 times 3 is equal to 81. 3 to the 4th power is equal to 81. X is equal to 4. So we could say log base 3 of 81 is equal to, I'll do this in the color I've used almost every color, is equal to 4. Let's do several more of these examples, and I really encourage you to give a shot on your own now that we get, and you'll hopefully get the hang of it. So let's try a little larger number. Let's say we want to take log base 6 of 216. What will this evaluate to? Well, we're asking ourselves, what power do we have to raise 6 to get to 216? 6 to the 1st power is 6. 6 to the 2nd power is 36. 36 times 6 is 216. This is equal to 216. So this is 6 to the 3rd power is equal to 216. So if someone says, what power do I have to raise 6 to, this base here, to get to 216? Well, that's just going to be equal to 3. 6 to the 3rd power is equal to 216. Let's try another one. Let's say I had, log base 2 of 64. So what does this evaluate to? Well, once again, we're asking ourselves, or this will evaluate to the exponent that I have to raise this base to, and you do this as this little subscript right here, the exponent that I have to raise 2 to get to 64. So 2 to the first power is 2, 2 to the second power is 4, 8, 16, 32, 64. So this right over here is 2 to the sixth power is equal to 64. So when you evaluate this expression, you say, what power do I have to raise 2 to get to 64? Well, I have to raise it to the sixth power. Let's do a slightly more straightforward one. Or maybe this will be less straightforward, depending on how you view it. What is log base 100 of 1? Let you think about that for a second. And this 1, so the 100 is a subscript, and then it's log base 100 of 1. That's one way to think about it. I could put a parentheses around the 1. What does this evaluate to? Well, this is asking ourselves, or we would evaluate this as what power do I have to raise 10 to what power do I have to raise 100 to get to 1? So let me write this down as an equation. So if I set this to be equal to x, this is literally saying 100 to what power is equal to 1? Well, anything to the 0th power is equal to 1. So in this case, x is equal to 0. So log base 100 of 1 is going to be equal to 0. Log base anything of 1 is going to be equal to 0, because anything to the 0th power, and we're not talking about 0 here, anything to the 0th power that's not 0 is going to be equal to 1.